Hello and welcome to the viewers. This is my business proposal, which names ZETA Propeller. First of all, is why do we do this? First of all, is a lack of locally made propeller for Indonesian IRL and aquatic vehicle, optimizing propeller efficiency at every phase of the flight or even the cruising speed. Reducing carbon footprint by using 3D printing and recycling of the 3D printed material. What do? We do design and analysis the design that we just made, and then consulting based on the customer preferences and manufacturing of the each propeller that are designed and analyzed. Our product consists of two main products, which is fixed pitch propeller and variable pitch propeller. And this is a feasibility study that we have bargaining power supplies, which comes from locally sorted supplier, and then we enhance the threats of new entrants by using the latest technology such as 3D printing, MATLAB, and ANSYS. And then the bargaining power of buyers with the increase in UV market and the flexible application of the propeller itself. And then the threat of substitutions, we provide greater efficiency and we have a consulting system to the propulsion mechanics of vehicle. And then the last but not least is the industry rivalries. The industry rivalries mostly occurs in the overseas market, which consists of European and United States company. And then this is the five bargaining powers from the Michael Porter. And it's the strength, weakness, opportunities, and threats for our company. The strength is giving customer the best propeller, giving consultation based on the customer needs. Weakness, the ratio between customer to employee would be very high, and there's going to be a small number of customers. Sorry. The opportunities, we are having a growth in UAV market segment, both in the world and also in Asia Pacific. The propeller is the most used mode of propulsion since it's the most simplest and the cheapest method. And the threats, customer wanted a cheaper product than ours, and customer wants a ready-made product that is not customly made. And this is model canvas. As we can see, we have a key partners, key activities, value proposition, and all the things. And this is our effective company organogram, which consists of the company itself and then chief of engineering, manufacturer, and human resources. The below chief of engineering, there's gonna be aerodynamics people, structural people, and then chief of manufacturer, we're gonna have a 3D printing technician, and storage management, and then supplier contactment. And then human resource, we're going to have company relations, so the relation between our company to the customer company or etc. And then the internal affairs to manage the internals of the human resources. And then here's the consulting plan. First of all, we have the customer requirements, and then we have the initial design. And then the initial design itself gonna be coming off from the aluminum sheet or 3D printed or servo motor and Arduino if the customer chooses the variable pitch propeller. And then the prototyping, we have some looping. We have revision. After the revision, we have to recycle the 3D printing, and then we redesign it again, and then ask the customer feedback for the maximum of 5 consultation with additional consultation with additional cost. And then if the design are accepted, then the design are saved in our ready-made inventory, and the proper itself is gonna be manufactured using aluminum first, and then the product is ready to be used for the customer either for flight test or the commercial uses itself. And then this is going to be our manufacturing plan. From the design, first of all, we're going to use mostly 3D printed materials due because of the test flight and so on. And then there's going to be going from filament, 3D printer, and then the section is going to be jointed by using another method, most probably gluing. And then the aluminum sheet is gonna come from aluminum sheet and then going to make the internal structure and then the outer shell. The internal structure and outer shell is going to be jointed by rivets and joints because uh, the regulatory bodies of Indonesia and internationally cannot really use welding technique as it has severe material weaknesses. And then the carbon fiber, we have a fiber and the resin, which is actually uh, the component of the carbon fiber itself. And then we're gonna use the technique injection molding and then curing using an autoclave, and then the propeller is made. This is our technology overview. This is going to be, as I explained, 3D printing. The MATLAB itself is going to be for the design phase and small analysis, but the analysis of the program itself is not really that, let's just say, not that accurate. And then we're going to use the ANSYS package for even more accurate results, as this is computational fluid dynamics software. And then this is our first month forecast, which assumption with the customer percentage and the total customer of 10 customer. As you can see, the final price and then the total estimated income is 66,600,000 rupiahs. That's all for me. From me, thank you for watching.